horsepower rating of a contactor or switch indicates the maximum motor load it can handle during continuous operation. The maximum current rating specifies the maximum current the device can safely carry without overheating or failing. The full load current of a motor is typically lower than the maximum current rating of the contactor or switch. This difference is due to the inrush current that occurs when a motor starts. Inrush current can be several times higher than the full load current, and if not accounted for, can cause the contactor or switch to trip. When selecting a contactor or switch for a motor, it is important to consider both the horsepower rating and the maximum current rating. The horsepower rating ensures the contactor or switch can handle the continuous load of the motor. The maximum current rating ensures it can withstand the inrush current. When a motor starts, it draws a significantly higher current than its full load current. This is known as inrush current, sometimes referred to as locked rotor current. This inrush current is temporary, lasting only a few seconds, but it is critical to consider when selecting a contactor or switch. If the contactor or switch is not rated to handle the inrush current, it can overheat, trip, or even be damaged. The horsepower rating of a contactor or switch is based on the motor's full load current. This is the current the motor draws when it is running at its rated horsepower and voltage. The maximum current rating is the maximum amount of current a contactor or switch can safely carry continuously, taking into account its ability to dissipate heat. To properly size a contactor or switch, one must consider both the horsepower rating and the maximum current rating. One should select a contactor or switch with a horsepower rating equal to or greater than the motor's horsepower. The maximum current rating should also be greater than the motor's full load current and able to handle the expected inrush current. Motor starters and contactors are designed to handle the high inrush currents associated with starting motors. They typically have a higher current rating than a standard switch of the same horsepower rating. This allows them to withstand the brief surge of current without tripping or being damaged. Understanding motor nameplate data is critical for proper component selection. The motor nameplate provides key information, including horsepower, voltage, full load amps, and service factor. The full load amps value is the current the motor draws when operating at its rated horsepower and voltage. The service factor indicates how much overload the motor can handle for a short period. This information is essential for selecting the appropriate contactor or switch and for setting the overload protection. Overload protection is crucial for protecting motors from damage due to excessive current draw. Overload relays are designed to trip when the motor draws more current than its full load current for an extended period. This protects the motor from overheating and potential damage. Selecting the correct overload relay size is critical. It should be sized according to the motor's full load amps and service factor. Electrical codes, such as the National Electrical Code, provide guidelines for selecting and installing motor starters and contactors. These codes specify the minimum requirements for wire size, overcurrent protection, and overload protection. Consulting the relevant electrical codes is essential to ensure the installation meets safety standards. Consider a motor with a nameplate rating of 10 horsepower, 480 volts, and a full load current of 14 amps. When selecting a contactor for this motor, you would need to choose one with a horsepower rating of at least 10 horsepower and a maximum current rating greater than 14 amps. The contactor also needs to be able to handle the motor's inrush current. The inrush current for a motor can be estimated to be typically 6 to 8 times the full load current. Therefore, the contactor should be able to handle an inrush current of approximately 84 to 112 amps. Many manufacturers provide data sheets that specify the inrush current capability of their contactors. These data sheets should be consulted to ensure the contactor is properly sized. In addition to the contactor, you will also need to select appropriate overload protection. The overload relay should be sized according to the motor's full load amps and service factor. If the motor has a service factor of 1.15, the overload relay should be sized to trip at 1.15 times the full load amps. In this example, the overload relay should be sized to trip at approximately 16.1 amps. Proper wiring is also crucial for ensuring the safe and reliable operation of the motor. The wire size should be selected according to the motor's full load amps and the applicable electrical codes. The National Electrical Code Table 310.15b16 provides guidelines for selecting the appropriate wire size based on the ampacity of the wire. It is also important to use the correct type of wire for the application. For example, THHN wire is commonly used for motor circuits. Proper grounding is also essential for safety. The motor and the contactor enclosure should be properly grounded to prevent electrical shock. The grounding conductor should be sized according to the applicable electrical codes. In summary, selecting a contactor or switch for a motor requires careful consideration of the motor's horsepower rating, full load current, and inrush current. The contactor or switch should be sized to handle the continuous load of the motor and withstand the inrush current. Proper overload protection and wiring are also essential for ensuring the safe and reliable operation of the motor. Regularly inspect contactors and switches for signs of wear or damage. Look for cracked or broken components, loose connections, and signs of overheating. Replace any damaged components immediately. A preventive maintenance program can help to extend the life of contactors and switches and prevent costly downtime. When selecting a contactor or switch, consider the application. For example, some applications may require a heavy-duty contactor that is designed to withstand frequent starts and stops. Other applications may require a contactor with special features such as surge suppression or arc quenching. The voltage rating of the contactor or switch must also be considered. The voltage rating should be equal to or greater than the voltage of the motor circuit. Using a contactor or switch with an inadequate voltage rating can be dangerous. The ambient temperature in which the contactor or switch will be operating must also be considered. The ambient temperature can affect the current carrying capacity of the device. If the ambient temperature is high, it may be necessary to derate the contactor or switch. The altitude at which the contactor or switch will be operating must also be considered. The altitude can affect the dielectric strength of the device. If the altitude is high, it may be necessary to use a contactor or switch that is specifically designed for high-altitude operation. It is important to choose a reputable manufacturer when selecting a contactor or switch. Reputable manufacturers offer high-quality products and provide excellent customer support. It is also important to read the manufacturer's instructions carefully before installing or using a contactor or switch. The instructions provide important information about the device's ratings, installation, and operation. Consider the number of poles required for the application. Contactors and switches are available with different numbers of poles. The number of poles required will depend on the number of conductors that need to be switched. Consider the control voltage of the contactor. Contactors are available with different control voltages. The control voltage must match the voltage of the control circuit. Consider the type of enclosure required for the application. Enclosures are available in a variety of materials and designs. The type of enclosure required will depend on the environment in which the contactor or switch will be operating. Consider the type of termination required for the application. Contactors and switches are available with different types of terminations. The type of termination required will depend on the type of wire being used. Consider the available space for the contactor or switch. Contactors and switches are available in different sizes. The size of the device must be compatible with the available space. Consider the cost of the contactor or switch. Contactors and switches are available at different price points. The cost of the device will depend on its features, ratings, and manufacturer. Remember that cheap is not always better. It is important to choose a high-quality contactor or switch that will provide reliable service. Consider the availability of replacement parts. It is important to choose a contactor or switch for which replacement parts are readily available. Consider the warranty offered by the manufacturer. A good warranty provides peace of mind and protects you from defects in materials and workmanship. After installation, it is important to test the contactor or switch to ensure that it is operating properly. Use a multimeter to check the voltage and current at the terminals of the device. Verify that the contacts are opening and closing properly. Regularly inspect the contactor or switch for signs of wear or damage. Look for loose connections, cracked or broken components, and signs of overheating. Replace any damaged components immediately. Keep the contactor or switch clean and free of dirt and debris. Dirt and debris can interfere with the operation of the device. Follow the manufacturer's instructions for maintenance and cleaning. Improper maintenance can damage the contactor or switch. If you are not comfortable working with electrical equipment, consult a qualified electrician. Working with electricity can be dangerous. Always disconnect the power before working on any electrical equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. Be sure to understand the electrical code requirements for your area. The electrical code provides guidelines for safe and proper electrical installations. By following these guidelines, you can help to ensure the safe and reliable operation of your electrical equipment. Always remember safety first when working with electricity.